In this video, I'll show you how to solve the ALEKS problem called balancing chemical equations with non-interfering coefficients. And what I'm going to do is copy this chemical equation down just so that I have a little bit more room. Fe2O3. Also, we don't need to have those solid or gas symbols. It's not necessary for balancing the equation, so I'm going to leave those off. Fe and O2. And notice that I'm leaving myself a little bit of space here because I'm going to be adding some numbers up here. So if you're new to balancing equations, or if you're working on an equation that's pretty tricky, one of the tips that I like to give people is to make a list of all of the atoms that's on the left-hand side of the equation, and then make that same list over on the right-hand side, and make sure that they're both in the same order, meaning that both of your lists have the atoms in the same order. And then what you're going to do is count up how many atoms you have to start with on the left-hand side. So to begin with, looking at our Fe2O3 on the left-hand side, the little 2 here tells us that we have 2 iron atoms, and the little 3 tells us we have 3 oxygen atoms. And now we want to do the same thing over on the right-hand side. We want to count up how many of each type of atom we have. We have only 1 iron atom. I know that because there isn't a subscript out here. There isn't a 2 or a 3 or whatever, so that means just a 1. And the oxygen, we have 2. To balance the equation, our goal is to modify stoichiometric coefficients so that, and that name sounds really intimidating, but we want to make modifications to the equation so that we have the same number of each type of atom. This equation will be balanced when we have the same number of iron on both sides and the same number of oxygen on both sides. And what I like to do is just work on one atom at a time. So we're just going to start by focusing on the iron. The iron atoms are not balanced because we have 2 on the left and we only have 1 on the right. We balance by increasing the amount of an atom. So in order to balance this, we want to increase the amount of iron on the right-hand side. Specifically, we want to increase it to 2 so that it matches the left. And the way that we increase the amount of iron is not by changing the little coefficient, or excuse me, the little subscript, but rather by changing the big number that comes in front of the formula. So putting a big 2 out in front here means that we have 2 irons, and instead of having 1 iron atom, now we have 2, and now our iron has been balanced. So since this is done, what we want to do now is focus on the oxygen atoms. We have 3 oxygen atoms on the left and only 2 on the right. So we want to increase the amount of oxygen that we have on the right. And the way that we do that is not by modifying this little number. We're not allowed to change this little number. It's a 2 forever, permanently. We cannot turn it into a 3. That would be really easy. All that we can do is change the coefficient, the big number in front of the oxygen. And I'm just going to increase it from 1, which is what it is right now. I'm going to increase it to 2. When I put a 2 here in front of this tells me that I have 2 O2 molecules. Each O2 molecule has 2 oxygen atoms. 2 times 2 is 4. So now I have a total of 4 oxygens on the left-hand side. I did that kind of fast, so let me kind of slow it down a little bit. The little 2 means that I have 2 oxygens, and the bigger 2 is telling me that I need to multiply those 2 oxygens by another 2 for a total of 4 oxygen atoms. Kind of tricky because it's a 2 and a 2, but we'll practice that again. So I did that, but that didn't really help my situation because now I have 4 oxygens on the left, but I only have 3 on the right. They're still not balanced. Now I need to increase the number of oxygen atoms on the left-hand side. And to do that, I'm going to do the same thing. I'm going to go to this molecule. I'm going to change its coefficient. I'm going to increase it from 1 to 2. Now I do have to be a little bit careful here. When I did that, I changed the numbers of iron and also oxygen both by putting a 2 out in front here. So I'm going to have to recount my iron atoms. My iron atoms at this point, I have a total of 4. I have a 2 times 2 is 4 for the iron. And for my oxygen, I have 3 times 2, which is 6. Kind of feels like I'm making everything worse, but I'm not. Just trust me. You kind of have to go back and forth a few times before this actually works. So our oxygens are still not balanced. That still hasn't done it. Now we have 6 on the left and we only have 4 on the right. That means we want to increase the number of oxygens on the right-hand side. So let's take that 2 and let's turn it into a 3. Let's just increase it by 1 again. Now we have 3 times 2 oxygens on the right-hand side, which is 6. And this is perfect. Now, whenever you get to the end of your list, like we did, it's a good idea to go back up to the top of the list and just double check, because in the process of balancing the oxygens, we unbalanced the iron, which means we're going to need to fix that as well. We have 4 iron on the left, but only 2 on the right, which means we need to increase this number. And maybe you feel brave enough to just jump this number straight up to a 4, because you can see that we need a total of 4 iron. That's going to fix that. So now our irons are balanced, our oxygens are balanced, and this equation is balanced. To fix this in ALEKS, what you're going to do is use your cursor, just click right here in front of the Fe2O3 and then type in a 2. Do the same thing, click in front of the iron and type in a 4, and click in front of the O2 and type in a 3.